Okay, I think we've got all the lights blinking in the proper order today. Let's hop on over as we stand by for another show. There's some space on either side of that thing there. That's fine, whatever. We're going to give it just a few minutes here like we normally do because it's time for another Intrepid Museum Virtual Astronomy Live. Y'all should be able to hear me, but we're still waiting for Twitch to realize that we're streaming. Actually, like 15 different places to realize that we're streaming here. There we go. It looks like it sent a notification because Squish showed up. Hey, how's it going? And thanks for the resub. We'll give it just a couple more minutes here for all the notifications to go out. If you hear me, type over there in chat. Just let me know that you can see what's going on because, like I said, it's time for another Virtual Astronomy Live like we do every month here with Intrepid Museum. Dave! Skapunk. Skapunk? I don't know how to say your name, but thanks for showing up, Dave. Hightower was in there as well. Regal. Thank you for showing up with the 5x5s as well. I see the 5x5, so I have a feeling y'all may be watching from somewhere else or may know us from somewhere else. Rex next. Thank you. Squish Chin. There was the resub. Appreciate you, Squish Chin. But like I said, it is time for another Virtual Astronomy Live. We're broadcasting basically all over the place right now. We've almost got our own deep space network. There's so many streams going out of my house here today. So Jax PDX, Rye Guy coming through as well. Thank y'all so much over on the Twitch side. And I'm going to check the other Twitch channels as well because we're also live on twitch.tv/Intrepid Museum. So if you're watching over there, tell me hi, say that you can see me in chat, etc., etc. Also, today we're live streaming on YouTube too. So if you're watching over on YouTube, Michelle Sokol, I see you over there on YouTube. Thank you so much for checking in at the very beginning of the show. We appreciate that. And then I think we're also live on Facebook. Good grief, we're basically live everywhere today. I think there's like 4 different streams going, but not seeing any chat over there. Get caught up, Facebook. Come on. Anyways, it looks like everything's sort of clicking along in order. The audio good? Like, y'all hear me okay? The problem is that I like changed the setup so many times over the course of a month, and then we do another Virtual Astronomy Live, and it's like, I hope I pressed all the buttons correctly. That one thing is jumping the way it's supposed to, so I'm pretty sure we're doing this correctly. And we got the 5x5s in chat, so I think y'all can hear me. So we've got a really cool, Jax, thank you. Appreciate the help. We've got a really cool thing to talk about today, NASA's DART mission. So if you remember, we actually streamed this. The launch, NASA Spaceflight had a camera over at Vandenberg, and we saw the DART mission launch. I really do hope that went from Vandenberg. There's so many launches going on. Anyways, we live streamed that here on the Twitch channel as well, and we saw the rocket go. The spacecraft intentionally on its way to crash into an asteroid. That's sort of the deal. Normally, you don't hear about spacecraft intentionally crashing into anything, but with the NASA DART mission, the entire point is to redirect the trajectory of an asteroid. Actually, the orbit of an asteroid around another bigger asteroid. The names are really funny. We'll get all into that later, but we're going to be talking with the one of the NASA mission managers for the DART program and who has some involvement in some other, I'd say, deep space exploration missions. So like we normally do, we're going to get a chance to hear from him. We'll have Summer Ash back here as well doing the moderation. They'll do a little bit of a discussion thing, and then into the show, we'll have time for Q&A. So if you had questions about why off of Earth NASA would want to crash a spacecraft into an asteroid, you'll have a chance to ask here at the end of the day. NSF, who's that? I know, right? I didn't really check if I was okay to wear this hoodie or not, but I'll just slouch down and have bad posture. Anyways. Let's go ahead and get our pre-show going here. The DART mission is going to be coming up in just a bit, starting around 5:30 Eastern, so 24 minutes or something like that. That's when we'll get our NASA special guest. But we start every one of these shows with a special guest from the Intrepid Museum. And today with me here, you've seen her on the show many times before. Please welcome Alicia Siegel. Alicia, how are you doing today? Oh, let's see here.
Nice to see you again. And hear me again.
Y'all should be able to hear Alicia just fine there. We had some waving, some pantomime there at the beginning, but now you should hear her just fine.
I'm basically one of those inflatable things at the car, you know.
the wacky waving, what is it?
That's me.
I can't say it. I'm not even going to try. Wacky
It's the mood.
waving inflatable tube arm guy? I
Yes.
don't know. Something like that. How's it going, Alicia?
Great. How are you?
I'm hanging in there. I'm ready to talk about crashing into some asteroids or something.
Oh, yeah, absolutely. So, yeah, tonight's Astronomy Live, all about the DART mission. In a bit, we're going to hear from Scott Bellamy, one of the mission managers in the Planetary Missions Program Office.
Yep.
He played a really big role in getting this thing up into space and on its way to go accomplish its mission of, like you said, smashing into something.
Intentionally.
But before we toss it over to him, I am going to talk a little bit about the idea of planetary defense in general, how we even plan for something like that too, should the need arise.
This is like the little triangular spacecraft that flies around and shoots at things, or like planetary defense. We have a shield or something. I think you have to get like a little Tiffany lamp.
Is very important. They are looking for asteroids. They're looking for, near Earth objects, making sure that they don't get up in our space here. They want to stay in space, stay in their space.
Not just about shooting them down, but about finding them in the first place.
That's correct. That's correct.
All right.
And, we've all seen the movies, right? We've seen, the Deep Impacts and the Armageddons, right? And there's actually another one coming out later this month with Leonardo DiCaprio, I think. So these movies with these giant asteroids or comets or planets or, coming to hit us, triggering, these big tsunamis and an ice age and mysterious electrical powers. Did you see that one? Melancholia. It was very weird. But in reality, I thought it'd be interesting to see what would happen in real life if that happened. Because NASA scientists are smart. They're always looking for these things, right?
Yep.
You'd think that we would know a little earlier, before something like that was on its way in for collision.
Hopefully.
And also, is it a good idea to send up a nuclear bomb to blow it up?
Wow.
Actually a good idea. So we're going to look at some stuff. All right.
Sometimes you do like demonstrations. You're not going to be like throwing a tennis ball into a plate of flour or anything like that, are you today?
No. I'll be showing you some other really cool visuals though, for sure.
All right.
And talking a little bit about some RPGs actually.
Oh, really?
So stay tuned for that.
Cool. Are we ready to roll the video?
Yeah, let's go for it.
All right, here we go. Again, y'all, this is Alicia Siegel with the Intrepid Museum doing a little bit of pre-show about planetary defense. Take it away, Alicia.
Yeah. Awesome. So first of all, pop culture often makes asteroids look very chaotic and random. I was doing this. They're these things that, we never see coming. They're zooming all over the place unpredictably, but that's not entirely realistic. Asteroids in reality are extremely predictable. They obey the laws of physics. They follow orbits that we can track far into the future, and their shapes and their sizes and their compositions can vary. They can range in size from hundreds of miles across to smaller ones that are, just a few feet. Some even have their own mini asteroid moons, which we'll get to in a second, or rings or even tails of rubble. And these are all actually really great things for helping us to learn about the origins of the solar system. But the most important thing to realize is that as long as we know they're there, scientists are able to run predictions and these fake scenarios on them just to be safe. So don't worry, if there is a big one coming to hit us, we will more than likely know well in advance. The ones that we do try to keep our eyes on, though, the most are classified as potentially hazardous. And these are the ones whose orbits come very close to a collision with Earth. They're large enough to make, a very significant impact. And there's a couple that NASA has their eyes on at the moment. One of them is Apophis that you can see here. It's named for the Egyptian god of evil and chaos. But again, not entirely chaotic. It was discovered in 2004. It's estimated to be about 1,100 feet across. And astronomers originally predicted that it would come very close in the year 2029, 2036, and 2068. But with more and more observations, they safely concluded that it will not be having an impact on any of those approaches. However, set your calendars for April 13th, 2029. Yes, it is a Friday the 13th, of course. It's going to actually be passing less than 20,000 miles from the planet. That is closer than many of our satellites and will be visible on the ground in the Eastern Hemisphere without a telescope or binoculars. Now, another asteroid, Bennu, that you can see here, is going to make a very close approach with Earth in September of 2135 and also 2182. Bennu is named for the ancient Egyptian bird god. It actually does pass by Earth about every 6 years, but those 2 years in particular, it's going to come really, really close. Though again, not directly impacting us, don't worry. But Bennu is actually of interest, not because it's hazardous so much as because of its composition. So scientists are already starting to think about how asteroids might one day serve as refueling stations for spacecraft, and Bennu likely has frozen water that might one day be harvested for astronauts or even processed for rocket propellant. So there's also this possibility too that asteroids might have some metals to mine, like iron and nickel. So these are just two of the almost 28,000 known near-Earth objects of the over 1 million known asteroids everywhere to date. And believe it or not, the total mass of all the asteroids in the main asteroid belt rather, combined is less than the mass of the Earth's moon. So we use this telescope here, NEOWISE, stands for Near Earth Object Wide Field Infrared Survey Explorer, helps the scientists to discover these every day, including which are hazardous. And what's cool is that NASA just released this app here, Eyes on Asteroids, to help visualize all these comets and asteroids. So check that out. But regarding these names of them, they're not very strict when it comes to naming asteroids. They actually say that the discoverer of an asteroid has the right to suggest a name for it. So that's resulted in asteroids named everything from, Vincent van Gogh and the Beatles. Here's their pages on the JPL website. There's also tributes for the crew that we lost in the Space Shuttle Columbia in 2003. Someone named one after their pet cat, Mr. Spock, which arguably has a larger meaning beyond the cat. And believe it or not, yours truly. Now, no, I did not discover an asteroid myself, but the Lincoln Near Earth Asteroid Research Laboratory has discovered about 500,000 asteroids since the 1990s. And in 2001, they decided to promote science education by recognizing middle and high school space and science nerds, just like me, who had the honor of winning international science competitions. So about 4,000 have been named in this way so far. And although I do kind of secretly wish that my asteroid would have a really close encounter with Earth, the chances of that are few and far between because the asteroids that they named for students were quite deliberately chosen to be very far away from Earth. So it is still a pretty amazing conversation starter, though, I'm not going to lie. But okay, for the sake of argument, let's say an asteroid's heading right for us. What would we do? Well, first of all, it's important to remember that Earth is hit by asteroids all the time. Every day, we are bombarded with over 100 tons of dust and sand-sized particles, even slightly larger pieces that glow as they burn up in the atmosphere, things we call meteors, of course. Generally, anything smaller than about 80 feet wide will likely just end up burning up in the atmosphere as it comes in, but it can actually have a big impact. You might recall February 15th, 2013, an asteroid about 60 feet wide, it's about the size of a 6-story building, slammed into the atmosphere over the Russian city of Chelyabinsk at 40,000 miles an hour. It broke up, but it created a shockwave that struck as many as 6 cities nearby, and it injured 1,200 people. So the explosion itself was actually believed to be 30 to 40 times stronger than the atomic bomb at Hiroshima. Now, you might be surprised to hear that a lot of asteroids about the size of a car or a house actually do come pretty close. In fact, just earlier today, there was one about the size of a bus that came within 130,000 miles of us. So that's actually only about halfway to the moon. We've traveled twice that far in space. But every 2,000 years or so, a bigger one hits. So say maybe about the size of half of a football field. And that's big enough to destroy a whole city on direct impact. Or if it happens to hit the ocean, it might actually create a wave that is about 6 miles high. But a really, really big one, about 20 times that size or about half a mile wide, would threaten all of humanity. It would instantly destroy anything about 60 miles in its radius, and it would cause so much dust going up into the atmosphere that it would effectively block out the sun for decades. And meanwhile, if it hit in the ocean, the amount of water that would be sent up into the stratosphere would cause an instant greenhouse effect. Now, in the 1960s, a giant asteroid called Icarus, named for, of course, the Greek who flew close to the sun, was predicted to make a close approach with Earth. And the asteroid itself is almost a mile wide, so it would definitely be hazardous if it hit us. But in this instance, one MIT class turned it into a thought experiment, and they ultimately proposed that if it was headed right for us, they would repurpose the Saturn V rockets that were intended to take the Apollo astronauts to the moon, but instead they would send out satellites to observe it. And if worse came to worse, they would deliver 6 100-megaton nuclear warheads to blow it up. Now, fun fact, no nuclear warhead that size even existed yet. The biggest bomb that the US had at the time was only 25 megatons. Also, there is actually an international treaty that prohibits not only exploding a nuke in space, but also even putting one up there in the first place. But if it was worst case scenario, we didn't have much time, it might be the most explosive force that we could use. So scientists said they'd cross that bridge when they get there. But one of the main problems with blowing up an asteroid is that it might cause it to shatter, or at least break off into smaller but still large pieces, and it might rain back down onto Earth. Kind of like, the Atari game Asteroids, where you've got these chunks that, are maybe harder to aim for, they're moving faster, but still causing a lot of damage. So aside from nuclear devices, in the event of an oncoming asteroid, others have proposed strapping massive rockets onto an asteroid to just steer it away, or using big lasers to slowly melt it away, and even having giant magnets potentially tug on asteroids that might have big metal deposits. So this is all where NASA's Planetary Defense Coordination Office, or PDC, comes in. And it's exactly what it sounds like. It's looking for potential asteroids or comets that might impact Earth, also known as near-Earth objects, or NEO, and doing their best to prevent them from reaching our planet by coming up with strategies and technologies, just like DART, which was just launched last month and which you'll be hearing more about later tonight. So it was built and managed by the Johns Hopkins Applied Physics Lab. It's about the size of a vending machine. It's got these long solar arrays coming out of it. And this is actually, as Das mentioned, NASA's first spacecraft mission to test out this asteroid deflection technique to change the motion of the asteroid in space. So what does that mean? In some ways, it'll sort of be like a bug smashing into a windshield at 15,000 miles an hour. It's done, it's flattened, it's staying there. But in another way, you can kind of think of it maybe like a game of billiards, only those pool balls are asteroids. You imagine they're moving through space, and the effect of the ball you're hitting is DART. So the thought is that by striking an asteroid with a spacecraft, the impact itself, as well as any of the materials that shot out from its surface, might change its speed or its direction, even slightly, in its orbit. And if it's far enough out, that change could really make a difference. Now, in particular, DART is aiming at Dimorphose, which is this little asteroid moon orbiting another larger asteroid called Didymos. Didymos is the Greek word for twins, appropriate. It's a binary asteroid system of two. And some have actually nicknamed the smaller one Diddy Moon. Isn't that adorable? Now, remember, though, this is a test. It's only a test. That asteroid is not going to be a threat to Earth at all. But it is a really great test case because it's easy to get to. It's just about a year away. And it's also observable by us here on Earth. So it's a great way to see if this technique will work, which is important because practice makes perfect. And we want to make sure that it does work before an actual planet-obliterating asteroid comes to hit us. Now, you might wonder, though, how do they come up with this stuff? How do they even think about these scenarios? Well, they are thought experiments, theater of the mind. They actually run what they call tabletop exercises. Now, if you're a huge nerd like me, you hear the word tabletop, one of the first things you might think of is, ooh, that sounds like a pretty epic Dungeons and Dragons campaign. And yes, by the way, Meteor Swarm happens to be a very powerful spell in that game. And actually, if that weren't enough, guys, D&D fans worldwide got super excited back in 2017 when photos of an asteroid that passed nearby showed what looked very much like a D20. It's a 20-sided die. This is asteroid 2017 BQ6. It has a really unique look. It's got many relatively flat sides that kind of suggest a polyhedral die with sharp corners there. It's about 660 feet across, rotates only once every 3 hours though, so pretty slow game. But anyway, what are these tabletop exercises, right? Okay, so on at least 8 occasions, they have come up with hypothetical scenarios about an incoming asteroid with fictional data to see how experts might respond. So the first 3 of these were conducted by FEMA, of course, and then about every 2 years since, they've happened as part of the International Academy of Astronautics Planetary Defense Conference, where scientists, lawyers, engineers, and emergency response people gather to effectively role play a made-up asteroid threat from its discovery to its impact. And you think I'm nerdy, right? Over the course of a few days, the conference team slowly reveals pieces of information, just like a real discovery and tracking process. And participants have to think through what challenges they would face, what choices they would make, and what information or plans maybe they wish that they had. So during this year's exercise, which happened online from April 26th to April 28th of this year, the scenario suggested that a new asteroid was discovered with a 1 in 20 chance that it would have a direct impact with Earth just 6 months away. And since this was only just discovered, they had very little information about its size. But based on its apparent brightness, they thought it would be about 400 feet wide, though it might actually range anywhere from 115 to 2,300 feet. They didn't know. The orbit around the sun lasted 516 days, and it was moving about 11,000 miles an hour. Now, based on this orbit, attendees realized that this scenario, well, it had passed by Earth in 2014, according to that. So they pulled more information from this instance. They were able to crunch more numbers and realize, no, it's not a 1 in 20 chance. It has a 100% chance of hitting. Nat 20, critical hit. Great. So as they got more data, they were able to pinpoint potential areas of impact with thousands of random sample cases. As you can see, they cover pretty much the entire planet. But as the data sets kept coming in, the regions at risk narrowed considerably. First to just a thinner corridor wrapping around Earth, and then to a very specific footprint location. But here's where the short time frame gets uncomfortable, because you remember this hypothetical date of impact was just 6 months away. So how do they respond? They could try the kinetic impactor thing. They could try to push it away. Maybe they could go the nuclear device route, try to vaporize at least part of it. But in reality, they realized that with just months to go, they wouldn't have any time for that. They would basically have already needed to have a spacecraft sitting on a launch pad ready to go at this point, and they didn't. But then they fast forward a bit for some good news. So now it's 2 months later, and thanks to high-powered telescopes on the ground and in space, they've narrowed the orbit just enough for the impact range to fall across Germany, the Czech Republic, and Austria. They've also clarified the size of the object to between 260 feet and 790 feet. Still definitely large enough to do real damage, but now eliminating the worst case scenarios, which leads to them simulating some realistic potential impacts and ways that they could respond to the damage. In the end, though, the planet was not faced with the worst case scenario. Measurements that were taken less than a week before this fake impact showed that the object was about 340 feet across, and it headed pretty much towards just a nice quiet forest between Prague and Munich. So a fun, hypothetical, nerdy little role play exercise if you're into that. But really, the point of these conferences isn't so much about where the fake asteroid ends up as it is the discussions along the way. They want emergency management people to talk to scientists about these things because scientific emergencies happen, and we're living in one right now with the pandemic. It can be really difficult to look at and evaluate risks that are completely unknown, and then have to figure out how to then turn around and communicate that information, or the lack thereof, to the public. So in actuality, it's great training. It's a wonderful exercise and very relevant to the world today. And yeah, while it might be a little bit nerdy to geek out on an imaginary scenario like this, they may actually keep us safe someday. So I say, here's to the scientific sorcerers, the clerics of the cosmos, and the paladins of the Planetary Defense Coordination Office. May they always keep us safe, or they can certainly try. Thanks for having me on again.
Did you write a script for that? You're just bang the entire thing out.
I just thought, well, it's all online. You can actually look up the proceedings of all of these past conferences. It's fascinating. It's over a period of a couple days. They leak out the information very slowly, and then everyone, comes together and brainstorms how to fix the solution. It's really interesting.
Well, they had a very forgiving DM here because it's oh no, there's an asteroid coming. It's not too big. It's hitting the middle of nowhere. It could have gone a lot worse than that.
Some of them have been worse. Some of them have been worse, but that particular one just ended up kind of in the forest. So.
No kidding. So if anybody out there is telling you that you're wasting your time by playing role-playing games, whether they're online or you're sitting down with your friends and pen and paper, tell them, well, that's how we simulate our disaster response to Earth-ending cataclysms.
Absolutely.
Legitimate strategy.
Absolutely.
Good deal. Y'all, it's always a fun time when we get Alicia to come through here. We always do these pre-shows. It's always a fantastic show, Alicia. Thank you so much for stopping in here this morning, this evening. I mean, how does the world work, right? It's whatever time zone you're watching in right now. But thank you so much for joining us this evening on the East Coast, I guess, right?
Absolutely. Yeah. Thanks for having me again. Always love to be on.
All
Have a
right.
wonderful Astronomy Live.
Sounds good. All right. Y'all, here is the trick. Let's see here. Always a good time with Alicia on the show. What I'm going to do, I'm actually going to hop off really quickly. We'll have the little be right back screen. One day we'll have, like, I don't know, an advertisement to play or something there. If I played an advertisement, then you would complain about, oh, why'd you have to play an advertisement? I'd rather watch the spinning shield. But I'm going to do that. And when I come back, I'm going to have our special guest from NASA Actual, mission manager for the NASA DART program, Scott Bellamy, will be joining me here in just a few minutes. You know how it is. We're a super tight ship around here. Not a lot of people, production rooms and stuff like that. Nah, it's like me and Alicia. So I am going to go to the Be Right Back, and when we come back, it will be time to talk to the NASA person, one person from NASA. So don't go anywhere. Again, spinning shield is a normal thing. The Be Right Back is going to happen. And when we come back, our special guest from NASA talking NASA's DART, the mission that is intentionally crashing a spacecraft into an asteroid to see if the asteroid cares about that. We'll be right back, y'all. Stand by for us. All right, folks, let's see if we've got the lights blinking in the proper order here, as you do. Let me know. You should see 3 people on the screen now, and you should be able to hear all of us. We've got Summer Ash and Scott Bellamy joining us. Let's go ahead and get going here, Summer, shall we?
We shall.
All
Yes.
right. Chat, let us know if you can hear everybody correctly. And Summer, if you want to take it away, I'll make sure that they're hearing you just fine.
All right. Thanks so much, Stas.
All right.
So welcome, Scott. Today we are going to be talking all about the DART mission, the Double Asteroid Redirection Test mission. Very exciting. And Scott, I'm just going to give a brief bio of you because it's very impressive, and I want to dive into some of it as well.
Okay,
So
sure thing.
you are a mission manager for the DART mission, and you're in the Planetary Missions Program Office at Marshall Space Flight Center in Huntsville, Alabama. And you're also responsible for the day-to-day oversight of the Europa Clipper flagship mission, which I hope that we totally have you back to talk about, because I would love to talk Jupiter and Europa all day, all the time. But you've also been the mission manager for the OSIRIS-X mission, which we did talk about this past year. Very exciting, the first ever United States asteroid sample mission. And you're currently working on DART and also the NEXT-C, the NASA Evolutionary Xenon Thruster commercial project, which is providing the primary propulsion for DART, and the Near Earth Object Surveyor, NEO Surveyor mission, to provide the capability overall for detecting low observable asteroids. So today it's going to be all asteroids all the time. And
somehow I ended up with asteroids. I'm not sure how.
Well, there's plenty of them, so I foresee, you know, missions forever in your future.
Possibly, yes. But in all fairness, I had to give up Neo SM when I took Clipper. I just re-inherited DART.
Got it. But I wanted to just start, I always love to ask people, how did you get into science, engineering, space in the first place growing up?
Well, it's actually for me a very easy story. When I was 7 years old, my mom still has a copy of the paper that I'd written when I was 7. I wanted to become an engineer, go into the Air Force, become a fighter pilot, become a test pilot so that I could get into the astronaut corps. Somewhere along the way, Mother Nature interfered and I ended up with glasses. So I went to the Air Force. I was an engineer, and then after 20 years of trying, I finally ended up at NASA. And so in 2008, I finally landed at the NASA Marshall Space Flight Center. And one of my career fields in the Air Force was scientific analyst, and so this was kind of a natural evolution to come over, and ending up in planetary missions was like bonus, and it was a great place for me to land after retiring from the Air Force.
I had no idea we had such parallel paths at different times, but I don't have a letter about being an engineer, but I have like a notebook that my fourth grade teacher asked us to keep, and it says like, I want to be an astronomer. But then I did the whole space camp wanting to go into the Air Force to fly, to get the flight experience, to be the astronaut. I too have eye issues and was a bit in denial at first. So I only lasted 2 years in ROTC, but
congratulations for the 2 years. I may have been a little bit overachiever. I lasted 25 and a half. So.
Yeah, so this is kind of like a whole second career for you.
Actually, it literally is. So I retired once, and now I'm wondering when I can retire again.
Well, not before, I hope, DART finishes its mission. So let's...
Well, that's in September, so I don't know if we have to worry about that.
So DART is already on its way to its target, right? It launched last month.
It launched just before Thanksgiving, depending on which time zone you were in, is either the 23rd of November or the 24th. And so it is on its way. It's about 150 million kilometers away right now.
And so there is a cool way that people can actually figure out where it is right now and follow it along, right?
Oh yeah, they can look at the NASA Eyes on Asteroids or NASA Eyes on the solar system, and they can zoom in and scroll around till they actually find it. So
I'm going to see if Ross can scroll around and potentially find that for us. But while he looks, what is the spacecraft consist of?
Well, it basically consists of its main propulsion system, the NEXT-C, 2 very long solar arrays. I can see that DOS may have a view of it up there. I don't know if anybody else can see that at the moment.
Yes, they can.
How long is very long for those solar arrays?
Oh, goodness. Now you're going to play Stump the Chomp. I actually don't remember how long the solar arrays are, but they are significantly large, and I would actually have to dig into, they're like almost 30-foot long by 7-foot wide for each wing.
I was going to say order of magnitude is totally fine here as an astronomer. Yeah. Just pick an order of magnitude and we'll go with
so that. If you take 3 average size bedrooms, like your guest room, 10 by 10. It's like 3 bedrooms side by side,
Okay.
and so
Large.
I just wrote large.
Yeah, large.
How's that?
I see that. And unfortunately, because they are the roll-out solar arrays, the operations team has had a few challenges during the this first month of spacecraft commissioning because the arrays are kind of floppy, and they're not super rigid like some of the normal solar arrays we have. And so they've already experienced a few challenges learning how to control the spacecraft when they try to maneuver it. They had some fun with that the day after launch, because when the solar arrays were trying to tilt, they would like kind of chatter a little bit as they were tilting. So they're learning, and they've conquered that one. So on to next fun things.
Yeah, and by fun you mean stressful.
True. Yes. And then actually this Saturday at about 4 p.m. Eastern, they're going to turn on Next Eve for the first time ever in space, and they'll start seeing how well it performs.
So for how it got to where it is now, it was just the launch trajectory, so to speak, and a couple like maybe smaller engine burns, or
they use their maneuvering thrusters for where they are right now. So they have a large assortment of little maneuvering thrusters scattered around the corners of the spacecraft, and they use that to adjust its attitude. And then they have some slightly larger ones where they can use it to push it up, push it down, push it sideways. But for the small stuff, like just kind of pointing it, they have very small thrusters, like very small thrusters, like on the order of Exactly.
Nice. Now you mentioned September is when it arrives. So what's the path? Is it sort of just pushing farther away from Earth, and then it'll be sort of
it's a direct intercept.
Yeah, and then catching up to it.
Yeah, so it will fly from Earth on a trajectory directly to the Didymos system, which consists of the Didymos, the larger of the 2 asteroids, and Dimorphos is the smaller. So Didymos itself is like 100 foot short of being a half mile in diameter, if you can imagine walking a half mile. So that's it's that huge. And then Dimorphos, its moonlet, is a little over 500 foot in diameter itself. And interestingly enough, we talked about OSIRIS-REx at the beginning. OSIRIS-REx went to asteroid Bennu, and Bennu is, just a little bit smaller than the Dimorphos that DART is going to collide with.
Oh, okay. You had a graphic, right, with some famous buildings or landmarks and the asteroid?
Yeah, that's DART chart. Yeah.
DART chart. Ah, there it is. The buildings were so small I couldn't find the graphic. I was like, where's the graphic of the buildings?
And so you can see on that image, which it won't let me open on my side for some reason.
That's okay. Josh got it up. Now I'm picturing the asteroid sitting in downtown Manhattan.
Oh, exactly. or maybe in Dubai, since you have the Khilafat Tower sitting there. But
Having never been there, I can't picture it there.
But yeah, it would make a nice dent in downtown Manhattan, certainly. But then you can see Dimorphos over to the side, 163 meters. But even that's larger than the Great Pyramid of Giza itself. Well, almost larger than. And then in comparison, you can see the little bus over on the far left of the graph.
I can zoom in, I think. Like if that's a thing, we can zoom in to see the bus.
and DART itself is significantly smaller than the bus. So
right, the spacecraft itself in the center.
right, and you can, if you pull up DART assembled, you can see kind of a nice size representation of DART, and you can, if you read it in the media, it says that DART is essentially the size of a refrigerator, but that's a very oddly shaped refrigerator if you think about it.
I want to do up my refrigerator in gold foil like that.
Yeah, have it in the kitchen.
I mean, on the size, this was one of the most, I'm going to use the term ridiculous pictures, because you have the entire Falcon fairing in this little bitty, it's like phenomenal cosmic living space, and a little teeny tiny refrigerator in the bottom of the fairing there. So
exactly. And originally the project wanted, DART to share a ride on somebody else's spacecraft, allow them to take the majority of the cost to launch. And then, kind of halfway along the way in development, NASA headquarters decided that no, there's too much attention on DART, so we want it to be a dedicated ride. We want it to have its own spacecraft with nobody else interfering with it. And so SpaceX stepped up to the plate and offered one of their previously flown Falcon 9s. But yep, they have more than a penthouse apartment for DART. And
I hope the spacecraft felt the luxury of that.
Yeah, I mean, it only spent a few days in there, so I'm not sure. I mean, I don't know if it got to walk around and explore all the spaces, but yeah.
That's kind of like the one time I got bumped up to first class. It was literally a flight from Denver to Albuquerque. So it was over before I knew it.
No meal service.
Yeah, not so much. So what's so special about this asteroid system, or how did this become the chosen target?
One, it flies very close to Earth's orbit. So there was, I think it was like 2013. It was probably the closest approach yet to Earth, and it offered a great potential in that there is negligible. There's zero, essentially zero chance of anything untoward happening after the impact. It provides a very interesting system to perform this assessment, because you have Didymos with Dimorphos orbiting counterclockwise, or clockwise actually, since Dimorphos spins counterclockwise. Didymos spins counterclockwise, and Dimorphos is in retrograde around it. Okay. So it's one of the, but the orbital period is 11.9 hours. So essentially every 12 hours you have a very stable system, and the mass of Dimorphos is small enough that a spacecraft the size of DART can impact it and produce a measurable change from the ground, and allow us to test the kinetic impact theory.
Yeah, okay, so it's close enough to Earth, which I think would also be important just because we can characterize it and then we can observe after the fact.
Yes.
And when we say close, we don't mean obviously close in any dangerous sort of way.
Oh, no, many millions of kilometers away.
Exactly.
So,
telescope close.
Telescope close. Radio telescope close.
That's a good point, that it needed to be a target that we could send a spacecraft to, where the spacecraft would have some measurable impact. Mm-hmm. So you can't really throw a David at a Goliath kind of situation. You have to limit your life.
No, we're throwing a basketball at Goliath, or maybe not even a basketball in this case. And I mean, talking about the size of DART itself, I think DOS, you have an interesting graphic to show how.
I think you could say that.
Well, I imagine throwing a cow at a Goliath.
And so I know we had a lot of fun with this in the couple of weeks ago. But when you look at the mass of DART, literally that Holstein cow there weighs probably more than DART does. So we have something the approximate size of a refrigerator that weighs a little bit less than a cow. And we're hoping to slow Dimorphos down in its orbit by, right now the estimates show that we may be able to get a 10-minute reduction in the orbital period. So as long as we get 73 seconds, we can see it from Earth, but we're talking 10 minutes.
Yeah, which seems like a not insignificant amount of time when you're talking 11 hours.
Yeah. And I mean, it will definitely be noticeable from Earth because as Dimorphos goes past the observable side of Didymos, and when the telescope can see it, basically shadow Didymos as it goes past, then we can measure, that transient time from here to here, and detect the change and how long it takes.
And so when the actual impact happens, will there be ground-based telescopes watching?
Well, the ground-based telescopes can actually see it. And originally we had hoped that the European Space Agency was going to have the sister spacecraft there with it. And that spacecraft was going to do real-time observations. It was actually going to arrive a few months ahead of us, and it was going to characterize the asteroid system before we got there. One of the ESA partners decided that they weren't really comfortable with funding the effort, and so that kind of got waylaid a bit. And so the team went back and they rescaled the spacecraft, but it's not going to launch until 2 years later. When we found that out, the Italian Space Agency stepped in and said, hey, what if we put a Cubesat on DART? And so what they are flying the Italian Cubesat. It's called Licia Cube, however we can pronounce that. I have not figured it out yet. I like to call it like a cube, but because cube is actually redundant in the name. Either way, so there's an Italian Cubesat that is riding along on DART, and approximately 10 hours before impact, or no, a little bit more than that actually, a couple of days before impact, the Leica Cube will detach from DART, and it will fly out ahead and establish a position where hopefully it can observe the impact itself. And then 2 years later, the ESA spacecraft will arrive and try to do a fuller characterization of what happened.
Like the ESA is going to do forensics.
Yes, exactly. They're going to measure the size of the impact crater and look at the evidence of ejecta on the surface, and understand how much energy was imparted between DART and the asteroid itself, how much went into just blowing junk into space.
Right. Das, can you bring back up the infographic? Because I think it had the little cube separate from DART.
How about that one? There you go.
Okay, so the cube's got its own little solar wings there.
And it actually communicates to Earth separately from DART, so it doesn't have to depend upon DART to relay its data back to Earth.
That's good, since DART's gonna,
cease to exist.
Yeah.
Did you get the DART-Moon-collision MP4?
Yeah, we've got that one.
If you could hit that one real quick.
Yeah, give me just 1 second to bring that up. There you go.
And now, yeah, I mean, this is called Terminal, and Terminal's not going to last that long.
That's an apt name, yes. Bam.
And you probably will, if we could be there for observation real time, you would see that energy release on impact.
And
so
the Italian CubeSat, what are the instruments that are on it that are detecting? Like, is it a camera or is it more some sort of like spectrometer? Or
it's actually in the 2 years I've forgotten, but I think it's a camera and maybe a spectrometer. But honestly, we were bringing that on as I rolled off to take on Europa Clipper, and I just kind of peripherally followed along on the CubeSat.
There's
I
only
can
so
tell
much
you
of
the
it.
6U, but
Yeah. There's only so many missions you can hold all of the info in your head. I would imagine.
It gets fun. Yes, definitely.
Yeah, I'm sure it's fun. Okay, so that's really interesting that ESA's going afterwards and then sort of taking stock. But in addition to the CubeSat and the data when the impact is scheduled to happen, then I would assume there's going to be follow-up. So can ground-based observatories, they're still able to do the period thing, right? They just can't
Yes.
the details
Exactly.
of the impact.
Right.
So then that's how we'll know that it worked.
Yeah, we'll have confirmation from the ground-based observations. We'll have some low-resolution observations of the impact event from Leica Cube. And so back to the camera versus spectrometer. So yeah, it's camera. So we'll have some optical observations of the impact event from Leica Cube. And then we'll have some very interesting observations from DART itself during terminal, because it will be imaging all the way down to impact.
Yeah, kind of like when Rosetta landed on the comet, and you've got those amazing close-up images.
Mm-hmm. So we're going to be downlinking at 300 bits per second on the high gain antenna all the way down to loss of signal. So everything's coming down all the way to impact.
Do you know if there's plans for sort of like a public viewing in the sense of like releasing those images in somewhat real time, or you're going to keep the card
I think
close
that's
to your
actually I think that's actually the plan, to live stream it. So we'll see how it unfolds between now and September 26th. But the last thing I heard is the plan to live stream it on the DART APL website.
Very cool. So DART is on its way. Oh, go ahead.
I was just to say I would have to confirm that with the communications person on the project, but that, to my best recollection, that was the last I heard.
Fair enough. So DART's on its way. So I assume that there's some sort of team that is, just monitoring the spacecraft itself. Is that the main thing that is just happening between now and then, or are there other things that the team is working on?
Well, between now and the end of this month, the team is working on commissioning the spacecraft. So they're bringing up systems like one of the first things that they did was they had to unlock and roll out the solar arrays, and then they had to unlock the high gain antenna and establish communications back to Earth but that was actually on the low gain side. So this month, basically right up until Christmas Day, they are bringing various subsystems online and characterizing the behavior. Like I said, this Saturday at 4 p.m. Eastern, they're supposed to bring the NEXC, the xenon propulsion system, online and do the first in-space firing of NEXC. And so that's another commissioning activity. They're going to, for the past couple of days, they've been activating the subsystems of NEXC, doing some conditioning on the components that allow it to actually start producing thrust. And then late Saturday afternoon, they'll actually turn it on and produce the first measurable thrust in space for NEXC. Key here is that with SpaceX being able to provide the launch service for direct injection into departure trajectory, NextC is no longer absolutely essential to completing the mission, and so the team is free to just run NextC as they can to collect data on it, and this is the operational debut of NextC, and so there's a lot of riding on the success of this, for the future of that propulsion system, because the dash C in that is commercial. So they're hoping to make this a commercial propulsion system available to whoever wants to procure it.
Yeah, that was my next question. So this is a new engine technology, or a new engine developed. And forgive my propulsion ignorance, I guess. Is xenon used a lot?
Is what?
Xenon.
You broke up a little bit. Yeah, xenon. The NextC is actually pardon the double use here. NextC is actually the next evolution of the ion thruster that was used on the Dawn spacecraft. And I see Dawson has pulled up an image of it there firing. So Next had its operational debut on the Dawn spacecraft, and I mean that worked for years perfectly fine. They took the design of that Next ion engine and worked to enhance it so that it was more powerful, had more thrust. Better efficiency, a better range of operation, and so the Next-C, the commercial version of it, provides a more versatile engine or more thruster. And I know that the Air Force has already expressed interest in it for some satellite systems that they're playing with. So it's not new.
Is that a picture of just the part?
That is a picture of the thruster being installed on the spacecraft. What you don't see Next-C and Next-C both, they have a lot of electrical components that go along with the thruster itself. So that piece is basically just the thruster assembly. What you don't see in the picture is this huge electronics box that has basically massive transformers to take lower voltage electricity and step it up to produce the high voltage that NextC needs to strip electrons off of the xenon and ionize that and produce the plasma, as well as the electronics necessary to create the magnetic field inside the thruster that guide the electrons out in the plasma as well.
And as you mentioned, so this is a spacecraft size engine that, like it's not a rocket engine, so it would be used on other spacecraft.
Exactly. And contrary to all of our Star Trek dreams, ion engines are not going to really be these large high thrust things that I'll even for the Star Wars fans, because I'm both, you're not going to fly a TIE fighter with an ion engine.
I was going to ask, what if we had twin ion engines? Would that be better?
Yeah, I have to. Lucas. Whichever part of Lucas came up with that idea, I have to mark them down some points on that one. I love X-wing fighters, but I don't know where they carry so much fuel for all those thrusters that they have.
Yes.
Another topic for Virtual Astronomy Live.
Critiquing science fiction spacecraft using real physics. That should be an entire show, honestly.
Well, I think that could be much more than an entire show. So I was only thinking that you just concentrate on the propulsion for one show.
A year's worth of virtual astronomy lives only critiquing sci-fi spacecraft. What exactly is an inertial dampener anyways? Like, how does it damp inertia?
Point.
Scott, what's your favorite thing about being like a mission manager for any type of mission? Is it, what all did you get your hands in?
It's, I mean, you get to play with, all these various different spacecraft from literally, which like the drawing board to, into mission and watch what happens in between. I mean, one of my coworkers, if you remember a few years ago, we flew past Pluto for the first time ever in human history. That's a guy that, his office was a couple of doors down from mine. And so you have all of these in the Planetary Missions office. We have all of, the inner and outer planet missions and asteroids and other small bodies. We don't have Mars because there's a Mars program office at JPL, but anything else like that comes along, it's in our office. And somehow we even required these small missions to the moon that popped up lately. So we don't do the sun either. Helios has its own division up at headquarters, but I came from the world of human spaceflight before I came into Planetary, and the narrow focus of human spaceflight compared to the solar system wide focus of Planetary is just amazing. There are just so many things that we're doing in just my office alone. It's stunning. And I ended up here, and I haven't really had the need or desire to want to move on since I got here. So it's been interesting.
So post-COVID, can I come visit your office and go planet hopping around the doors next to
you? Sure.
That sounds awesome.
Yeah, once we move back into the office, we're still. Right. I'm surprised you didn't actually ask me to open my spreadsheet today. So today is the end of week 92 of working from home.
And is this spreadsheet literally just a day and the word home, and a day and the word home?
Well, no, it just says days and weeks. So
yeah, wow, that's a lot.
Well, unless you want to know the age of our COVID puppy, I've also calculated that off to the side.
I got COVID kitties myself.
Oh, okay. Let's see. She's 36.4 weeks old today. Okay.
Of course, there's a spreadsheet.
Yeah. Now I see why you wanted to look up the solar arrays and not do an order of magnitude answer.
Yeah, unfortunately.
This mission is just so cool to me because I was thinking of, I mentioned how I did kind of briefly go the aerospace route at the beginning of my career. And so when I first started out in aerospace was when Armageddon came out, which putting aside their technique, but still just a bunch of aerospace engineers going to watch that. And now just over 20 years later, we actually have a mission going to an asteroid to try one of these techniques. It's kind of incredible.
I know. It's see, there was Armageddon, and there was another one. I can't remember the name of the other one now, but we had two movies around this. Can't remember.
I think that one was around the same time too, I think.
It was.
It was a little bit better. What's the coolest thing about this mission for you?
I don't know if I can answer that part of it. I can answer it, but I don't know if I can answer it. If that makes any sense.
That kind of makes the answer even cooler. So,
but yeah, I think the coolest thing has been watching the team persevere and continuing to plow through this to get launched. We were supposed to actually launch a few months earlier. COVID kind of reared its head and messed things up a little bit. But seeing them continue to just beat down the obstacles that got in their way and make it to launch day, and watching the team on launch day regardless of the mission is always the best part, because the jubilation on their faces as they realized all of this hard work and effort, and to have a successful launch. It was like DART launched, came off the pad 20 milliseconds after the opening of the launch window for that day.
Wow.
And so when you look at that, and you have to give the launch team credit for being able to have a vehicle that and the vehicle launch systems that were required to achieve that kind of timing. 20 milliseconds into it. But yeah, they did. So
speaking of the team, roughly how big is the DART team, or sort of, I guess, the central DART team that's looking at?
Yeah, that's actually always a hard number to keep your thumb on, because you have the team at APL proper, and then you have the extended team for the subsystems, and then roughly I think the APL prime team is a little over 100 people. Now, if you want to, I can pull up the monthly chart so we can go through those if you wish, so we can look at all the manpower numbers and things like that. I'm joking, by the way. I don't want to discourage people.
Sometimes I'll go down those rabbit holes.
I was like, I don't want to discourage people by showing them, monthly charts. That's the last thing we want to do.
I love working on spacecraft. Yeah. I
Here's
noticed
the fun part.
Yeah. Speaking of fun, I noticed on the APL website there is an option to become a planetary defender. Do you know anything about this?
I saw that myself, but I didn't click the link. But I was and the only reason I didn't go back to it is my computer rebooted or something, and I didn't remember it until literally just now. But I did see that same link.
Have to take a quiz.
There's a quiz? I don't just get like a patch or something?
Short quiz. Nope. You gotta test your knowledge first, I guess. There's got to be some sort of, entry qualifications.
All right.
Oh, let's do it.
I brought up the quiz. Earth is hit by asteroids all the time. Need a hint? Sure. I don't know. Program manager, mission manager, could you tell me whether or not Earth is hit by asteroids all the time?
True.
But is that a trick question? Is it like, well, actually, they're hit by meteorites, or they're meteoroids?
Right.
Oh, yeah, that's a good point.
I don't know.
Which way does that one go?
Chat,
they're not being pedantic.
What do y'all think, Chat? Is this a trick question, or is this like, yes, it's hit by asteroids all the time? I'm going to click it, and if we don't pass, then no, well, that's correct. All right, cool. NASA established a Planetary Defense Coordination Office in 2016 to, need a hint? Identify and track, study strategies and technologies, coordinate the U.S. government's planning.
All of the above.
Do you think all of the above, Summer? All of the above?
Yep.
All right. You know, we're doing the quiz now, right? It's question 2 of 5.
That's done.
Correct.
Exactly.
All right, hang on. What's the name of the first mission to come out of NASA's Planetary Defense Coordination Office? Is it the, Duo Android Reconnaissance Test, the Double Asteroid Redirection Test, the Double Asteroid Rendezvous Trip, or the Dispersing Analogous Robot Threats?
I really wanted number 4, but
Oh, jeez.
I want number 4 to be real is what I want. Really.
Dispersing Analogous Robot Threats? Nice. Let's go with the Double Asteroid Redirection Test. All right. Look, 2 more questions. We're doing okay. How many asteroids are in the Didymos asteroid system? Is 1, 2, 4, or 9? Well, that would be the number of planets. Anybody?
I don't know. Pluto got demoted, so
Anyways. I'm gonna go with 2.
Sure.
It's pretty much yes. All right, it's correct. Look, 1. I think we've already passed, so we're like already a shoe-in on the guess here, or on the test.
We're at 80% right now. That's
Yeah,
a good.
We're 80%. We could just
Gotta be.
we could make this one up. What will the DART mission aim to do at Dimorphos, an asteroid moonlet orbiting a larger asteroid named Didymos? Send a gravity tracker to fly alongside the moonlet for a long time? Didn't hear about that. Use a nuclear device to break Dimorphos up into smaller pieces? Didn't hear anybody talking about that. Did you fill out the paperwork for that, Scott, the nuclear device, or no?
No, that takes too much trouble.
Okay, too much paperwork for the nuclear device.
Yeah.
Fly an impactor spacecraft into the asteroid moonlet at 15,000 miles per hour to give it a shove. Known as the kinetic. I like how this one has extra information on it. Or just vaporize it with lasers. I think that I learned on today's Virtual Astronomy Live
What did we learn today?
that it's an impactor spacecraft. Pretty sure. I'm going to click that. Look. Finish. It certifies that Das Valdez is officially declared a planetary defender on NASA's Double Asteroid Redirection Test. I should print this out and put it on my wall. You can download your certificate. Look. Now,
I hope all the viewers today are doing this.
Oh,
and
no.
putting those badges.
I can share my badge on social media. You dare me to do that? Look, it says I am a planetary defender. I like this. It's a certificate. Yeah, Kurosaki, it's a certificate. I had to click through that real quick, y'all. I sort of sidetracked us here for a second. I think I'll share this on social media. Back to you.
That was fun. See, I do like those things though, because I hope, that they're kind of maybe bringing in a younger set and engaging them and getting them interested.
Definitely.
We just
our planet.
We gave away all the answers though.
Well,
Maybe
I mean, you help.
He shares it with a cousin or brother or sister or a friend, then you just perpetuate it so the whole planet is taken care of.
I'm tweeting. Y'all talk. I'm tweeting. My
You're
badge.
tweeting.
I just thought you were practicing Klingon on Duolingo.
Do they have that on Duolingo, actually?
Probably.
I've never looked that up.
That might be something.
Look, I just tweeted it and said this was done in a totally legitimate manner. This was only my work. I had no help with this small quiz that made me a planetary defender. I'm going to post the link in chat if anybody else wants to do it too.
Honor code.
Oh, goodness.
Where was DART actually built?
It was built primarily at APL's facilities in Maryland.
In Maryland,
So,
yeah.
Just outside of Washington, D.C. on the north side. There's a few pieces that, like NextC was built up at Glenn Research Center in Ohio. The solar arrays were built, I think that facility's in California. I'm not sure. I have to check that one. Mm-hmm. And then various other components were built at some other places, but for the most part, it was built at APL. The Goddard Space Center, they did some work for DART, but Goddard's just down the road essentially from APL. And So yeah, it was built almost entirely there. I mean, you
And
can.
then was everything sent to APL and then finally put together before going down to put in the launch vehicle?
Yeah, and so they had the launch site got changed from launching from the Kennedy Space Center to launching from Vandenberg, so they had to come up with a shipping container for DART. And we debated, for a few months on whether to fly DART to Vandenberg or truck it. And so they actually decided to put the shipping container on a tractor trailer and drive it cross country. So it left on a Saturday and got there a little bit later that same week. And then they pulled it into a processing facility out at Vandenberg and started doing the final preparations and fueled it up. I mean, you saw the picture where they put it inside the fairing, and after they got it enclosed in the fairing, they put it on another truck and took it over to the processing facility for the launch vehicle and put the fairing assembly on top of the launch vehicle and took it out to the launch site.
I'm very glad to hear that DART was not affected by the trucker shipping shortage.
No, they had their own. That made it a little bit easier. When you have your own tractor trailer that you can put it on, then that helps things a little bit.
We had a fun conversation 2 times ago about the transportation of JWST. So now imagine all of these spacecraft being hidden in these nondescript semis and boats that I see with trailer with containers.
Yeah, we usually
imagine.
Yeah, we usually prefer to put those in Air Force C5s, but sometimes things just work out better. Well, I mean, in the case of James Webb, you didn't really have many other options. You needed a really smooth ride and it was a really huge container. So yeah, putting on a boat and sending it down through the canal was one of the only options they had. Why we had to put DART onto a tractor trailer, that's just what they worked out as the most practical solution to getting it out there. There was a lot of shipping on an Air Force C5 involves a lot of extra work to coordinate with the Air Force, get things lined up. You have to have somewhere where you can land to load the spacecraft onto the aircraft, and then, well, obviously flying to Vandenberg, they wouldn't have had any problems with where to land, but or flying to KSC for a launch, it's no problem there. When we're shipping stuff from Denver, it's actually a lot easier than you think. They just put the spacecraft in a container and drive it off the mountain to an airport that's relatively close to the Lockheed facility there in Denver. But there are some challenges. You have to work your way through them. But driving cross country in a tractor trailer, it's like you don't want to stop, so you have multiple crews. You have more than one crew. So you've got a crew driving and a crew at rest because you don't want to park at your local Marriott and leave it sitting out in the parking lot all night.
It's like in a Motel 6 that. You know how they park long ways and they take up lots of spaces, and it's like the DART spacecraft. No big deal.
Yeah, not many people think of the logistics challenges of the things that are happening in the background just to get to the launch site. But even like some things, depending on the spacecraft or depending on the components, sometimes you're talking about, you don't just put those in the mail. Sometimes they hand carry those. They'll climb onto an airplane with the courier in one seat and the component in the next seat, they hand carry it. And we just actually on Clipper, we just had that scenario where they had to hand carry something from one spot to the next to do some testing. So
do they have the the briefcase handcuffed to them?
Well, it was a pretty big box, so it wasn't exactly handcuffed, but
It's like being handcuffed to a refrigerator that's being moved cross country. Like,
Yeah, I love those little stories too, because there's things that NASA has to do that we all have to do about like moving hardware and just shipping something and moving people.
Yeah.
And sometimes there's really interesting stories there.
oh yeah, if we were talking about Osiris Rex, I'd have several to share with you.
Well, we are talking about, small bodies in the solar system. So if you have a choice one you would like to share, we are happy.
Osiris Rex has had the Osiris Rex laser altimeter, which is an acronym that turns into OLA.
Mm-hmm.
And OLA was built and provided by our friends in Canada. On the day they were trying to bring OLA into the country, our friends on the American side at Customs was not going to allow them to bring it into the country. Because somebody did not file the correct form. And so they had people sitting at the airport trying to get stuff delivered, but Customs wanted the correct form. Does this not sound like a nightmare movie?
Yeah, although I feel like it does all come down to the paperwork.
Unfortunately, it does.
you should have just showed him your spreadsheet. Like, you could just print out your spreadsheet and be, here's the paperwork. I don't think it works that way. It's wishful thinking.
No, but Osiris Rex had a lot of instruments on it. DART technically does not even have an instrument on it. It has, if you want to pull up Draco integration to Spacecraft, DOS.
Got it. Quickly. There you go.
Yeah, that is the closest thing to a scientific instrument that is on DART. It's the telescope that will be used to find the Didymos system at first, about 10 hours before arrival or impact. That's an 8-inch telescope, and the Didymos system will look a single pixel of light, just one tiny little square of light 10 hours out. And we are depending upon that one single optical instrument and the software living behind it to find Didymos, lock onto it, track us into the system, and then finally, once we get within 3 odd hours of impact, to find Dimorphos, center it in the frame, lock onto it, and guide us into impact. That's essentially it is an instrument, but it's really, I don't know how you classify it, because it's not a scientific instrument as much as it is part of the guidance, navigation, and control system.
Its science is, can I crash into this using this picture? That's the science of
yes.
it.
But we are the spacecraft itself impacting Dimorphos is the science of this mission. There's not science being done separately.
I think the science is whether or not this single C-clamp here holding the telescope on is really the right way to do that. I mean, I don't work for NASA or anything, but I'm not. I see like an ESD clamp there to ground it out, but I don't see any other C-clamps. Maybe hidden on the other side. Maybe it's got some pins or something I don't see. I don't know. Not questioning NASA or anything. It's
Well, I'm looking at the size of that elephant stool it's sitting on, wondering what on earth are you guys actually looking at there?
the photographer was there with the smock and everything and the camera, so they had to look busy. Here, hold this wrench. What is like a little? Yeah, it's like a little wrench. There's a little ratchet with a little hex key or something on the end of it. A little extension in a hex key. How about that?
They were just like, stand here and look like you're doing something.
5 minutes previous, they were, you know how you do you spin the ratchet around and it makes the ratchet noise? Probably not. This is a serious clean room environment. Or, not. Is this a clean room, or is this doesn't look like clean because they have pants on?
No, that's a clean room.
Is it technically?
Yeah, it is. I mean, they've got the hairnets and the masks and the smocks.
Okay.
And I don't know if you can see, but they probably have bunny slippers on their feet too.
Yeah, I don't see any feet. Not that you don't normally wear pants in the clean room, but it's like a full bunny suit versus the smock sort of thing. I didn't know if there was a difference.
It was just the difference is the cleanliness level classification of the particular clean room. So that's
right.
Maybe that's a 10,000, a 10K clean room versus 100K. Who knows?
Gotcha.
This is everything else on the spacecraft in that shot looks like it's pretty well zipped up. So, I mean, even Draco in the foreground of the image, I mean, it's already packed and sealed. So.
Yep. There's a sign over there that says "Do not touch." LGA something. Do not touch. So. I like looking at the images. It's like a photo hunt sort of thing.
Oh, the low gain antenna.
Oh, low gain antenna? Is that what that means? Caution LGA.
Yeah.
Uh-huh.
Yeah, don't grab the horn. You'll mess up the antenna.
So it's not like a handle to move the spacecraft around or anything. It's the antenna.
Nah.
Aha. And there's a handy printed out sign there that reminds you of that fact.
Yeah, Das, you're one of the reasons why people have to be so careful of releasing these types of photos.
No, it's not like that. I'm just showing that I'm very interested in the project. They should release more images like this so that I can look at them.
Okay. Yeah, agreed. I don't think I realized that what you were just saying about the 10 hours out and the 3 hours out, I didn't realize it was that short a time frame. And like that late into the mission that was taking place and that was being targeted and pointed. Wow, that's not very long.
No, it's not. And you consider the velocity, I mean, the magnitude is what, 15,000 odd miles an hour? So, and no, that's not very long at all. You've got, the terminal is at last 10 hours. We have a pixel that shows us where Didymos is, and in the next 10 hours, we have to be able to resolve Dimorphos and target it. All the while, the big floppy solar arrays are giving you fits.
I like the solar array animation there, the floppy solar array animation.
And, you've flown on a wide body aircraft, right? Like a 777 or something.
Mm-hmm.
And have you ever bothered looking out the window after takeoff and noticing that the wing is like way up in the air like that?
Yeah.
Uh-huh.
Yes.
Unfortunately, the Dart solar arrays are doing it in both directions every time you fire the thrusters. So they're hoping for a very, very precise targeting solution that allows them to just cruise straight in. And because every time they fire the thrusters to try to maneuver themselves, they're going to get oscillations in the solar arrays.
Now, Scott, is that final targeting an automated process or?
Oh yeah, it's all autonomous. No, it's all autonomous. And once, I'm not sure what the one-way light time at that point is, because I'd have to sit down and figure out where Didymos is going to be Earth relative on that day, and I haven't actually done that yet. But you figure the one-way light time is going to be many minutes long. It's not going to be. It probably won't be 20. That's Osiris-Rex to Earth was 20 minutes during impact or contact. So I think it's on the order of 10 minutes, 8 to 10 minutes. And so now the terminal would be fully autonomous. Yeah, they'll send up the last set of commands just before they let it go, and then from then on in, it's watch it happen.
Yeah, exactly. Holding your breath, fingers crossed.
Yeah.
Yeah. We've got a whole stack of questions here. If you'd like me to start going through some Q&A. Don't worry, I went through them. I got rid of all the fun questions, and we'll just do boring questions. No, I'm kidding. All the questions are fun. Is that cool? Can we start doing some Q&A?
Oh, yeah. I'm fine.
All right.
It's summer show, but she should answer then.
Summer?
No, it's question time.
All right. And y'all, over the course of the show, if you had a question for us, you can always put your question in, and then I've got some cool software on the back end here that'll pull the questions out, and in the last 30 minutes we usually do Q&A. So you can still put a question. I've got room in the queue for more questions. Just say, I have a question, and then put your question, or start your question with the word question, because it's literally the text string question that picks up the fact that you're asking something. I guess I could do like question marks too, but whatever. It's not overcomplicated here. So if you have a question, you can add it to the queue now, and I'm going to be going through some of the ones that came in over the course of the show. And we're going to start with this one from Kit344. Does DART have any explosives on board apart from the remaining fuel? We say kinetic impactor. That doesn't mean explosives.
No, it's literally just the fuel that's remaining in the tanks. And at that point, I can't give you a number of kilograms.
Yeah.
But at that point, we will be down to basically into our margins on fuel. So just whatever is theirs, that's it. There's no embedded explosives. It's all just the vaporization of the metal.
Gotcha. And you don't, even if there's a little bit of fuel left, do you expect the fuel to explode? 15,000 miles per hour, it feels like the fuel is just going to cease to be fuel. I don't know.
Yes. If they're everything spacecraft, all spacecraft components will be converted to energy, and you will get a flash of light.
Yep.
And instant vaporization of everything there.
Gotcha. So we're not moving the asteroid by exploding something or like an explosion, a chemical reaction that is releasing energy. We're literally just crashing into it with something that has mass, and that's what's making it move.
Right. It's every bit of the kinetic energy converted to a reaction.
Gotcha.
And you will have, and we have to be able to, there will be, what we have to figure out is, it's harder to explain this than I thought. So here's the impact, and it's not a rigid surface.
Right.
It's not like the cue ball hitting the 9-ball, where you have basically no deformation of the surface. In this case, you're going to have deformation of the surface combined with release of the ejecta, the mass that gets blown off the face of the asteroid.
Yep.
And so we have to somehow resolve how much energy went into causing mass to release from the surface versus the energy that went into retarding the asteroid in its orbital path.
Gotcha. So it's not a perfect transfer of energy. It's not like a physics equation that you may have to do where it's like, oh yeah, F equals ma, and then this goes here, and it's all perfectly, all the numbers add up, right? Like some of the energy will be wasted. I don't know if that's really the right terminology, but if your mission is to change the orbit, it's wasted?
No, if any energy that went into release of ejecta is wasted.
Right.
So yeah, wasted is probably a good term.
Gotcha.
And we'll be able to, and probably for some of that answer, we're going to have to wait until the ESA mission makes it to DART to look at the ejecta, look at how much is surrounding the impact site itself.
Yeah. And I guess another part of that is you're trying to hit it right on the center of mass, but some of your energy, if you don't hit it exactly right, may go into actually rotating the asteroid instead of slowing down its orbit. There was this demonstration the astronauts did on the ISS that sort of illustrates this, where, let's see if I've gone to the right spot here. They're literally throwing bags of stuff at each other. But if they don't get it exactly right, all right, come on, throw the stuff. You'll see that the astronaut actually rotates some instead of just moving back, right?
Mm-hmm.
So same sort of story there, where if we don't hit it directly on the center of mass, we may actually rotate the asteroid a little bit and change its orbit at the same time. Yes, no?
I won't say it's not possible to impart some rotational, get some inertial transfer to rotational inertia.
Right?
That's not my area, so I don't probably want to get too deep into commenting on that part, especially since I haven't pulled out my textbooks in so long to actually.
No spreadsheet there on the other monitor that you could refer to, like.
No, moments of inertia was something I didn't always find that much fun, but
and probably not well simulated in Excel, I guess, right?
no, and I don't have MathCAD or MATLAB on my system anymore, so.
All right, I'm going to keep going through some questions. And y'all, if you have questions, remember, put them into chat. Just start your question. Yeah. Assume two spherical cows collide in a frictionless plane or whatever. Exactly, Wonder
I
Kim.
forgot our spherical cow reference.
Yes, the spherical cow reference. Let's see here. Here's a good question. We talked about the Alicia Cubesat. And the question was from Saber in Space, asking, is there a plan for how long the Cubesat will remain operational to observe Dimorphos post-impact? Because the Cubesat's just going by. It's not going to hang around, right?
Right. And I can't remember, but it has, its total battery life is measured in hours.
Right.
And so but I'm not certain how long it will actually remain operational after the event. And so when they designed it, they wanted to give it, enough battery life to last for as long as it could with, the limited size solar arrays that it has.
Gotcha.
So it's not going to last forever, but it will, hopefully get some great pictures and transmits those down, and then after that it's just sailing off.
It's just gonna keep going, no slowing down. And I guess a good thing there. It's like y'all thought about this. You said earlier that it can contact Earth directly, so it doesn't have to relay its signal through DART. It actually talks straight back to Earth, which makes sense because It's going to keep going after DART has not kept going. It's maybe a nice way to put it, right?
Yeah. And so another limiting factor there is, the size of its antenna being able to continue transmitting back to Earth. Even if it keeps going for days, eventually it's going to get to the point where its antenna is too small to transmit a signal with enough strength to make it home.
Gotcha. All right. Let's see here. Here's one. This is sort of going back to the rotational thing, so we'll just ask it. Saber also asked, after DART impacts Dimorphos, will NASA only be observing the change in orbital period, or are they also going to try to detect if the collisions cause any rotation or change in orientation, like any other things that you're going to look for? This, I guess you have the little flyby and then the follow-up mission, right?
It would have to be with ESA's follow-up mission. From the ground, we wouldn't be able to detect we shouldn't be able to detect that much in a change of rotation of Dimorphos. You can see the artist, what do they call it, the artistic illustration of what they think Dimorphos looks like. But the ground telescopes, the radio telescopes can basically, they can resolve Didymos. And that was detected first in 2006 or 7, I think.
Yeah.
No, 1996. But it wasn't until like 2013 before they finally detected Dimorphos, crossing by occultation. So there's some that we can observe from the ground, but not a lot. So we're going to need, somebody there looking. And it'd been nice if ESA could have made it. Flew their original mission to get there before we did. They're not, but at least we'll be able to maybe see what happened. Obviously, if we get there and the impact point is moving in a circle, or around the center of mass, then maybe we gave it some rotational inertia.
Yeah, Makes sense. And I mean, we're going to go out there and learn everything we can about it, right? That's why we're sending the mission in the first place, and why where ESA is doing sort of a follow-up, so we can see what we can see, right?
Oh yeah, definitely.
It's almost like we don't know what we don't know yet, so we need to go find out. Let's see here. Here's one from Masadi. Does the main spacecraft do much else other than speed up and smash into the big rock? That's basically it, right?
That is basically it. It's all. I mean, the DART is the main spacecraft,
Yep.
and I think that's what we're talking about here.
Yes,
It's just
yes.
DART, and it's it has the velocity it has at the moment, which was imparted by the upper stage of the Falcon 9 on release.
Yep.
Next C is, since we're no longer depending upon Next C for mission completion, all the maneuvers that they do with Next C are going to be basically, if this is the trajectory of DART, we're just going to maneuver around the trajectory.
Right.
Mm-hmm.
So we're not going to increase the velocity with Next C. We're just, we've gone from Next C has been able to move from an operational necessity to basically it's its own experiment at the moment.
Right.
Riding with DART.
Gotcha.
Yeah.
With the Next C, like a question about that, is it going to do something where we talked about the telescope that's going to acquire the pixel, and then it's going to try to determine the smaller asteroid and sort of zoom in, and we're going to use that to basically do the trajectory so we can crash into it? Does the programming have anything where it's like, all right, I have a lock, floor it, and then it's going to burn the rest of its fuel going faster towards it? Or it's just like, all right, I have a lock, I'm already going 15,000, don't need to do anything else?
Now the gas thrusters that are situated in the corners of DART, they will fire to keep Dimorphos centered in the frame of Draco.
Yeah,
exactly. So I mean, Draco will have like a targeting reticule on it, and so the job of the thrusters and the software is to keep Dimorphos locked into that frame. So if it starts drifting off, the thrusters will try to fire a little bit to move it back. So I mean, if you like to, I mean, I don't know how many people out there probably have flight simulators, and they like to fly the jet fighter ones. So you've got your targeting reticule, and you're following the red guy, and you're trying to shoot him.
Yep. Keeping it in the center, huh?
Yep.
Scott, with all of your love of Excel, have you ever used the flight simulator in Excel?
Oh no. The Excel flight simulator?
Yeah, it's like an Easter egg. I don't know if it's still there, but back when I was in aerospace, it was there. There was like a certain keystroke you do, and a flight simulator comes up.
I wonder does anybody in chat know if that's still a thing? Can you do the flight simulator in Excel still? Oh, or is this something we lost whenever we went to all this online spreadsheets and stuff?
Well, it doesn't work in Google Drive, I'm pretty sure.
It doesn't work. Nice.
No, I was I can't remember which one it was I had, but I had the force feedback stick, and the rudder pedals and that stuff. I had the PC version, the tower version.
Oh, here's another question. From that last question was from Rhubarb, by the way. Sorry, Rhubarb, I sort of stole your question and acted like it was my question, but it wasn't. Do we floor it once we get a lock or anything? That was from Rhubarb there. Here was a question from, let's see here. Oh, well, this is one from Rhubarb as well. If DART performs as expected, are there any follow-up missions to hit any other body in space? Is there like DART 2, now it's payback time, or something like that?
I haven't heard that there are missions on the list of missions being proposed at the moment. So at the moment, all I can say is no, there aren't. They'll probably see how well DART behaves, and then based on the success of DART, then that will open the door for more missions in the future.
Yeah.
And back to his previous question, it's like, well, you can't floor it because you need that constant velocity, because that's part of the equation to figure out what your impact kinetic energy was. So
gotcha.
so,
So you
so
don't.
you take something out, leave velocity constant.
Yep, you don't want to be changing that variable so that the rest of your math is easier to work with, I guess, right?
Yes, exactly.
I hadn't thought of that. That's a really good point. It's not about maximizing the energy that you hit it with. It's about hitting it with a known amount of energy so that all the rest of your math works.
Exactly.
I like it. All right. And
so now
go ahead.
No dart.
Go ahead.
Dart harder.
Dart harder? Is that what you said?
Dart harder, like die harder.
Like die harder. Oh no. Dart with a vengeance or something. One of my NASA spaceflight buddies was joking when Dart launched that this was like payback for the dinosaurs. And it's like, here we come, asteroids. Now it's payback time, and we're launching a little refrigerator to smack into an asteroid. I'm sure the dinosaurs appreciated that, Chris. Thanks. Let's see here. We already talked about the Cubesat. The Cubesat isn't going to last forever. It is intending to miss the asteroid and continue going, but it's got limited battery and limited solar arrays and size of the antenna and stuff, like you said, Scott. So we had already sort of talked about that one. Let's see here. Why not send 2 darts? I mean, why not send 2? Funding? I don't know. How does that work? Can you just order like a stack of darts?
So actually, the one of the guiding principles of DART is to try to demonstrate that we can do this cheaper than we usually do our missions. So there was an intentional effort to simplify and reduce, is probably the best way to say it, the amount of overhead we put onto the development of missions.
Yep.
So we tried really hard to keep the cost of DART below a certain threshold. Now, to be perfectly honest, that didn't prevent bureaucracy from intervening in a couple places and causing a price to have to go up. But if you look at the normal price of a deep space mission, and this is still a deep space mission.
Yep.
And DART is significantly below that price, and so this is the first time we've done it. So there's no desire for this to be a one-off. Back to the earlier part, it's like we hope that there is a follow-on. There were some challenges keeping DART going in the early days. And then it finally became a congressional directive to, get this finished.
Yeah.
And there's essentially, it's not a companion mission, but it's a complementary mission, the Neo Surveyor that we talked about at the very beginning.
Yep.
That goes out and sits, has a parking spot out ahead of us in orbit, and it sits there and looks for asteroids that we can't usually see. So there is a desire that this not be the last, that this is like the first. We'll have to see how well it does, how great a success the mission has, and then we'll see what evolves from that and what we can continue doing.
Yeah, because it's sort of like designing a planetary, I'm going to say planetary defense mission, like a technology demonstrator, whatever you want to call it. I know there's all sorts of ways to talk about it, but it's not like you went down to the DART store and you could have got like 10 for the price of 9 or something like that. There's no discounts if you buy lots of darts yet. Maybe one day.
Yeah.
All right. Let's see here. There was. I'm just trying to find some questions here. Oh, when they were moving it cross country, did they label the DART shipping container? Did it have like a graphic of DART on the side and says NASA's DART mission? It's payback for asteroids, or was it just a generic shipping container going down the road? Have a NASA logo on the truck or something, or?
No, it was very nondescript. It was a plain white shipping container with the required weight information on the outside of it and nothing else.
No like big DART logo or anything like that. I mean, you could have been driving right next to a spacecraft at some point. You got to keep this in mind.
That's what I'm saying.
Drive safe out there. I sort of pictured, we said that it was like a refrigerator, right? And I pictured like one of those U-Haul trucks that has the scenes from America painted on the sign. Because they have some. They have some that have spacecraft. I've seen the VLA as well, Summer. And they have these U-Haul trucks, not sponsored by U-Haul, that have these like paintings on the side. And I could imagine Dart being in one of the little U-Haul trucks with a picture of Dart on the side, and it's like the refrigerator with the blanket over the top of it strapped to the wall, and you're driving it over to Vandenberg. But that's not how it works. It's just a white shipping container.
No,
Okay.
yeah.
No. We can dream.
It was, if you've seen the tractor trailer driving a bulldozer down the road, that's called a lowboy trailer usually, because it's low slung in the middle.
Yep.
And so Dart was on a lowboy trailer that had soft ride shocks on it, so that it wouldn't get bounced around. But other than that, it was a boring white container.
Just going down the road. There you go.
How you're giving us hints for looking out for potential spacecraft.
Kurosaki says it said not a NASA spacecraft really big on the side, so nobody would suspect that it was a spacecraft.
That's funny.
Oh, let's see.
Don't look here. This is not the box you're looking for.
This is not the box you're looking for. Along that, it's just really interesting because that's some of the background information that we don't think about a lot. It's like, wow, launch day and SpaceX and a Falcon launched it. Oh, it's crazy. It's going to crash into an asteroid. But you had to move it somewhere on a truck. So I had a question. Did mission personnel ride with it? Was it like the truck driver and then one of the engineers sitting in the other seat and they're sort of like switching off? Was there a convoy, like two cars following behind? Or how does that work when you move a spacecraft?
So it was an APL truck, so it was APL personnel driving it, and they had a chase vehicle with it. So they did have a chase vehicle.
Okay.
And so that they could keep going. It's like somebody was sleeping somewhere, so they had a truck with a sleeper on it, so that somebody was in the bunk while it was driving. So they traded off like 8-hour shifts.
I'm super curious about this because it sort of brings it down to earth. It's like all the things that happen behind the scenes to get us to launch day and to get us to Dart meets asteroid day. I don't want to call it impact day or whatever. But I mean, do they just pull into a regular gas station and gas up like a semi truck that's carrying Amazon boxes or something? Or is it like a they just pull in?
They stop at Love's, or they stop at what's the other one? Pilot or Travel
Pilot or something.
They stop at a regular truck stop.
No kidding. Go in and get a candy bar just like the rest of us do. Is just have the spacecraft on board. It's just
they have to stop at the way station just like all the other tractors.
No kidding. It's so curious because we always think about the big exciting events and the launch day and stuff like that, and a lot of people don't realize the years worth of work and all the little tasks. It's like we had to move this to another room, and then we had to bolt these two things together, and we made sure their bolts were there, and like all the little things that have to happen. I know, wink wink, right? All the little things that have to happen to get to launch day and to get to mission day, I guess you could say. Like a lot of times people don't think about that, and it happens.
Yeah. And one of the worst days of your life is when the bolt patterns don't line up.
Oh. See, for me, when I'm doing something and the bolt patterns don't line up, I can hit it with a sledgehammer, or I can drill some new holes. NASA's not looking over my shoulder. Whatever. I'm gonna get this to line up. I think it's a little different with the spacecraft, huh?
Oh, just a little bit.
Nobody's allowed to be in there. It's not like you just get a clean sledgehammer and start whacking on it. It's the only difference.
Yeah, it was like 2 odd months ago or something like that. The bolt hole pattern didn't line up on Europa Clipper's solar array. So,
no kidding.
So they had a panel where the hinges were supposed to attach to the solar panel, and the bolt holes had been drilled to the wrong pattern for that part of the array, and so fortunately for one of them, they were able to take that panel and flip it over and use it somewhere else.
No kidding.
That was a nightmare. The day that we thought that we had 3 full panels that might not be able to be used because they were misdrilled.
Well, hey, at least somebody didn't just like slather some epoxy on it and send it to space, right? That's good. Let's see here. I think we have time for just one or two more questions. Here was a question. In the CG, I guess in the computer graphics, it looks like the main part of the spacecraft is gold colored. Is it actual gold foil on the spacecraft? And why was it wrapped in gold foil?
Gold foil is the best, for deep space spacecraft. It's the best foil that we can use to help keep the spacecraft cool inside.
Okay.
Most people don't think about it because space is so cold, but the electronics inside the spacecraft are generating so much waste heat that you don't want to add solar heating to it. You want to be able to regulate the temperature inside the spacecraft. So not only are you keeping it from gaining extra heat from solar heating,
Yeah.
also somewhere else on the spacecraft there are radiators that carry heat away from the inside to dump it out into space.
Yeah.
And gold foil is one of the best external coverings from the blankets that are surrounding the spacecraft, because it's actually multi-layer insulation. So you have the gold foil on the outside, then you have several layers of other stuff going through, because not only is it providing protection against thermal load balancing,
Right.
it's also a micrometeoroid insulation. So you don't want little rock blasting around out there, ripping through your spacecraft and turning it into space junk.
Yep.
So,
Before you smash into the larger rock. Like, you don't want a smaller rock to crash into you before you crash into something bigger.
Yeah, that'd be a bad end to your party.
Yeah.
You want the crash you planned for.
It's nice, the crash you planned for. That's a really good thing. Like, a lot of people don't realize that. You have like your vacuum mug, and it keeps your coffee warm all day, or your drink cold all day, or whatever, because it's got a vacuum, and it's hard for the heat to move across the vacuum. There's no air molecules to bounce around on and to get away with, right? In space is the same thing. Your spacecraft is like it's in a huge vacuum mug, and the coffee in the spacecraft would stay hot all day. It's the electronics in the spacecraft that make it heat up, and the spacecraft actually needs to get that heat, get rid of it somehow. That's how you said the radiators and stuff like that. So the insulation that keeps the sun from additionally adding heat into your spacecraft is why the foil is there, right?
Yes.
Of the many reasons, or of a couple of reasons, I guess, huh? Yeah, it's just a good analogy, because a lot of people, oh, it's so cold in space, oh, the spacecraft is going to freeze. The problem with spacecraft is that they overheat if you don't get rid of their the heat energy that builds up.
And not really an analogy, but the JWST, James Webb Telescope.
Yep.
It has a huge mirror, and the mirror is coated with a gold film.
Right.
And it looks like it's this big, monstrous piece of gold that's going out into space. But the gold film itself, it's like, I think it's less than a cup of gold that's spread across all the mirror surface. So it's hardly any gold at all comparatively. It just, looks nice.
It just looks nice.
I think even in our event on that, they said it was almost just like the gold in a thick wedding ring.
Yeah.
I wasn't sure of that reference, but I would have to go back and double check it. But it's a minuscule amount.
It's not very much gold, yeah.
Yeah.
Let's see here. One last question. It's 7 o'clock here. Let's go one last question from Saber here. Do you know if there's a notable difference between the gold multi-layer installation and silver, like James Webb uses? Did DART get like the better insulation, or is there some difference? Why do you choose one or the other?
Actually, that's a point that I hadn't bothered paying attention to. I didn't know that James Webb had silver on its outer blanket.
Huh.
And because all the other spacecraft I've played with, they've all been gold, and I just didn't pay attention to it. But it's essentially just how much albedo do you need on your spacecraft?
Okay.
How much reflective power do you need? You obviously don't want it to be black.
Yep.
And the albedo of gold and the albedo of silver they're going to be slightly different. Yeah. So how much? Just how much reflectivity?
How much
do you need?
reflectivity you need? Gotcha. It's not like,
Right.
well, geez, we already spent our $10 billion. We can only afford silver. We can't splurge for the gold. We're out of money on the James Webb here, which is hopefully launching soon. By the way, coming up, I think I didn't see that press conference today because I was preparing for this, but there was some news. Chat, fill me in if James Webb gave us some information. Is this still like Christmas Eve or something? Anyways,
That's what I heard yesterday.
yeah, that's what I was hearing too, but I didn't watch that conference today. That does bring us up slightly past 7 o'clock, which is the end of our virtual astronomy live shows. We could just sit here and hang out with you, Scott, like talking about spacecraft and engineering and science and kind of making jokes about stuff because it's a fun way to learn things. But we could sit here for another hour, but it is time. It's Summer. Go ahead. What'd you say? Sorry.
Oh, we could just take more quizzes all night as well.
We could. We could figure out what spacecraft type we are, like all sorts of stuff. But it is 7 o'clock, and Scott, thank you so much for joining us here today. It's always good to be able to talk with somebody who's directly involved with the mission, hear some little anecdotes and behind-the-scenes story, learn about the mission and the science. Just thank you so much for taking the time out of your evening to join us here today. Tonight.
Oh, thank you so much for having me. It's been a lot of fun. I really appreciate it.
All right.
Hope I haven't misled anyone.
Me too. I'll hear about it after the fact if you did, but don't worry, I won't forward the emails. I'll send you the good emails. So if chat, people that are watching, if you have compliments, send them on and I'll share them with Scott and NASA. If you don't have something nice to say, at least say something funny. In any event, that does bring us to the end of the show today. Also, you've seen her on the show multiple times. Our moderator, Summer Ash. Summer, thank you so much as well for joining us.
Always fun. Oh, thank you, Scott.
It's always a good time. And y'all, we are going to continue Virtual Astronomy Live into 2022. So there is an entire slate of new shows coming up, and we are planning on continuing them coming up in January. In fact, in January, the next Virtual Astronomy Live is going to be Thursday, January 20th, and it's going to be on NASA's Artemis 1. Which is a planned... I know. Oh, I'm going to read this part, which is a planned uncrewed test flight set to launch in February.
Yeah, my wife and I already have reservations down at the Cape, so we can go watch.
Oh, no kidding.
Because my wife works human landing systems, so she's part of the team trying to build to put the next female, or put the first female, the first person of color on the surface of the moon.
There you go. Excellent. So that's going to be the topic of our...
family.
Yeah.
Do what?
Go ahead.
You're a NASA family.
NASA family.
Yeah, actually, literally, yes.
Excellent. And remember, y'all, you can also visit intrepidmuseum.org. I'm doing like the housekeeping here, Scott. Visit intrepidmuseum.org to learn more and to pre-register for next month's events. Also, you can visit the museum in person. If you happen to wake up in New York City for some reason and not know why you're there, you can at least visit the museum. It is open 7 days a week. There are some special requirements to visit, so make sure you go over to intrepidmuseum.org to learn more about how you can visit out there. And also, remember, the live streams don't just do themselves. There's an awful lot of clicking that I have to do on occasion. And also, Virtual Astronomy Live is supported through a NASA cooperative agreement awarded to the New York Space Grant Consortium. So thanks to them for the funding that allows us to continue to do these monthly STEM outreach shows. I'm not going to put that in air quote shows because it's always a good time, and I hope that y'all have learned something here. But for now, Scott Bellamy, NASA, thank you so much for joining us this evening. One more time, we really do appreciate your time. And Summer Ash as well. Always a pleasure having you on the show.
Yes, thank you so much.
All right. So, folks, you know what to do if you want to make sure you don't miss these going forward. Follow the channel. If you're watching on twitch.tv, make sure you go to twitch.tv/Intrepid Museum. They've got their own channel that have shows almost on a daily basis. Also over on YouTube, like and subscribe or whatever the kids are saying. We were on Facebook as well, and I have no clue what you're supposed to do there. I'd have to ask my mom how we do something on Facebook. So, anyways, however you were watching the show today, we hope that you enjoyed it. That is the end of today's Virtual Astronomy Live, and we will see y'all later. Thanks so much for joining us. It's like outro music and stuff. We can dance and wave. Anyways, thanks, y'all.
Bye.